Welcome to SOC Mantra and welcome to another video of our Cisco Networking CCNA Lab series. In this video, we'll do a router on a stick lab using sub interfaces. So in our previous video, we used multiple interfaces on a router for multiple VLAN communication. So in this lab, we will use single interface on the router for multiple VLANs. So before that, let's check some advantages and disadvantages of the router on a stick or one-armed router. So what are the advantages? Advantages of the router on a stick. So it's cost efficiency. So router on a stick is cost effective because it uses a single physical interface on the router to connect to multiple VLANs. This reduces the need for additional hardware such as multiple routers, which can save on equipment costs. Simplified network management. So router on a stick simplifies network management since all inter-VLAN routing is centralized through a single router. This makes it easier to configure and manage routing protocols and security policies. Scalability. The router on a stick method is highly scalable. As your network grows and more VLANs are required, you can easily add them without significant changes to the physical infrastructure. Traffic isolation. Router on a stick ensures that traffic between VLANs is isolated. This isolation is essential for maintaining network security, preventing broadcast storms, and controlling the flow of data between different segments of the network. Efficient use of router resources. Since a single router handles inter-VLAN routing, it can efficiently use its resources for routing functions without unnecessary redundancy. This can lead to better performance and resource allocation. Let's see what are the disadvantages. Limited bandwidth. The most significant disadvantage of router on a stick is the limited bandwidth. All traffic between VLANs must pass through a single physical link, which can become a bottleneck if there is a substantial amount of inter-VLAN communication. This can lead to network congestion and reduced performance. Increased latency. As you know, the concentration of traffic through a single router interface can introduce latency, especially during periods of heavy network usage. This may not be suitable for applications that require low latency, such as real-time voice and video communications. And it's a single point of failure. Router on a stick introduces a single point of failure. If the router or the link to the router fails, all inter-VLAN communication will be disrupted, potentially leading to network downtime. Suboptimal performance for large networks. Router on a stick may not be the best choice for large or high traffic networks. So as you have seen the advantages and disadvantages of the router on a stick, let's do it practically. So here I have taken one router and I have taken three switches and we'll configure three VLANs. So what is the objective? We have to configure VTP server on the switch 3 and VTP client on switch 1 and switch 2. Configure trunk interfaces on switch 1, switch 2 and switch 3 and configure the router as a DHCP to assign IPs to all VLANs. So what is the first task? Connect the router with switch 2. Let's connect the router. Here you can see the interface connections. So we will connect the devices accordingly. For the R1, fast Ethernet 0/0 is connected to fast Ethernet 0/24 of the switch 2. So let's go ahead and connect it. Fast Ethernet 0/0 to the fast Ethernet 0/24 of switch 2. On switch 1, fast Ethernet 0/1 is connected to fast Ethernet 0/1 of switch 2. Let's connect it. Fast Ethernet 0/1 is connected to fast Ethernet 0/1 of switch 2. Switch 1 fast Ethernet 0/2 is connected to fast Ethernet 0/2 of switch 3. Fast Ethernet 0/2 is connected to fast Ethernet 0/2 of switch 3. Switch 3 fast Ethernet 0/3 is connected to fast Ethernet 0/2 of switch 2. Fast Ethernet, fast Ethernet 0/3, and you can see in the diagram all these interfaces will be connected as configured as trunk interfaces. So what is the next task? Enter global configuration mode and assign the host name respectively. Let's go to the router. Enable configure terminal host name R1. Let me go to the switch 1. Enable configure terminal host name SW1. Switch 2. Enable configure terminal host name SW2. Switch 3. Enable configure terminal host name SW3. Okay, so we have assigned the host name, connect switch 1, switch 2, switch 3. This task is done. Configure switch connections as trunk connections. So before that, we have to configure VTP server switch 3 and VTP client switch 1 and switch 2. So let's go ahead and connect, configure. So as the lab's objective, configure VTP server on switch 3. Let's open switch 3, VTP mode. You can see we can type in as server. So device mode is already server, and we have to have a domain name for the VTP domain. I'll be taking as socmantra.com. Enter, and switch 2 and switch 1 will be VTP client. Let me configure VTP mode client. Here conf t VTP mode client. So these two will receive the VLAN information from the switch 3, which is the VTP server. Okay, VTP domain socmantra.com. Here VTP domain socmantra.com. Done. Okay, now let's create VLAN. As per the lab, it says we have to configure VLANs, VLAN 10 IT, VLAN 20 HR, VLAN 30 sales. So let's create it on the server so that it will replicate on the VTP client. VLAN 10 name IT exit, VLAN 20 name HR exit, VLAN 30 name sales exit. Let's see. So VLAN brief, you can see we have configured VLAN 10, 20 and 30. So for the VTP clients, to get the VLAN information from the server, we have to configure the interfaces as trunk from the server to the client. So let's see what are the interfaces here. VLAN fast Ethernet 0/2 should be configured as conf t. We go to the interface mode, fast Ethernet 0/2, switch port mode trunk. Okay, fast Ethernet 0/3 interface, fast Ethernet 0/3 switch port mode trunk. Okay, now let's configure interface fast Ethernet 0/1 and 0/2 on switch 1, fast Ethernet 0/1 switch port mode trunk, interface fast Ethernet 0/2 0/2 switch port mode trunk, exit, configure the same interface fast Ethernet 0 slash interface fast Ethernet 0/1 switch port mode trunk. Okay, let's check the trunk interfaces. So interface trunk and fast Ethernet. We can see here, and we have to configure it for fast Ethernet 0/3 as well. Conf t interface fast Ethernet 0/3 switch port mode trunk, exit, show interface trunk, and now you can see for fast Ethernet 0/1 and 0/3 on the switch 3 are configured as trunk, and the encapsulation used is 802.1q. Okay, now we have configured the VTP server, VTP clients, and VTP domain, and we have also configured VLANs on the server. VTP server show VLAN brief. Let's see if the VLANs are replicating on the VTP client. So VLAN brief. Wow. Now you can see VLAN 10, VLAN 20, and VLAN 30 are replicating on the other switches as well. Show VLAN brief on the VTP clients. Okay. Now we have configured the VTP server, we have configured the trunk interfaces, configure router as a DHCP to assign VLANs. So on the tasks, we have configured switch connections, we have created the VLANs. Now we have to configure the access ports. So let's connect according to create access ports on switch 3 fast channel 4/5. Fast Ethernet 0/4 is connected here. Fast Ethernet 0/5 is connected here. Fast Ethernet 0/slick is connected to VLAN 20. Fast Ethernet 0/7 is connected to VLAN 20. And on switch 2 and fast Ethernet 0/8 is connected to VLAN 30. Fast Ethernet 0/9 is connected to VLAN 30. So here you can see fast Ethernet 4/5. So we have to configure access ports on the switch 3 conf t interface range fast Ethernet 0 slash 425 switch port mode access switch port access VLAN 10 exit interface range fast Ethernet 0 slash 627 switch port mode access switch port access VLAN 20 exit interface range fast Ethernet 0 slash 829 switch port mode access switch port access VLAN 30 exit. So now we have created the access ports as well. Now the task is create sub interfaces on the router according to the VLANs. So let's go to the router and you can see here sub interfaces fast 0.10 for VLAN 10, fast Ethernet 0.20 for VLAN 20, fast Ethernet 0.30 for VLAN 30. So let's go here, enable, configure terminal, interface fast Ethernet 0 slash 0.10 and we have to assign the IP address 192.168.10.1 IP address 192.168.10.1 255.255.255.0. You can see here you have to configure 8.802.1q encapsulation for the sub interfaces to configure IP address. So we have to put in the command encapsulation.1q and let's give the VLAN ID 10. So this should be command for creating the interface and I assign the IP address. Okay, now let's see if we are able to assign the IP address 192.168.10.1 255.255.255.0. Now you can see we are able to assign the IP address. Similar way, we have to create other sub interfaces. Interface fast Ethernet 0 slash 0.20 for VLAN 20. Encapsulation.1q VLAN ID 20. IP address 192.168.20.1 255.255.255.0 exit interface fast Ethernet 0 slash 0.30 encapsulation.1q VLAN ID 30 IP address 192.168.30.1 255.255.255.0 exit. Now as it suggests we have created the sub interfaces on the router according to the VLAN IDs and we have also assigned the IP addresses according to the sub interfaces created. Okay, now let's turn on the interface fast Ethernet 0 slash 0. Interface fast Ethernet 0 slash 0. Now shut. Okay, now we have turned on the interface. Now the other task is configure the router as a DHCP server. Exit. Now for configuring the DHCP server, we need to create a pool for every VLAN that we have created. So the command is IP DHCP pool. So the pool should be IT for the VLAN 10 and we have to provide the network 192.168.10.0 subnet mask 255.255.255.0, default router or the default gateway that we have to assign to the PC. The default router is the router IP address or the sub interface IP address of fast Ethernet 0.10, that is 192.168.10.1, and exit. We have to create another pool, IP DHCP pool HR. Network is 192.168.20.0, 255.255.255.0. Default router 192.168.20.1. Exit, and IP DHCP pool sales network 192.168.30.0, 255.255.255.0. Default router 192.168.30.1. Exit. Now let's see the running configuration. You can see we have configured the pool IP, and IP address will be assigned from this pool, and we have created three pools for three VLANs, and we have also created sub interfaces on the router, three sub interfaces, and we have also assigned IP addresses to all the three sub interfaces. Okay, now let's see. You can see all the interfaces are up and we should be all up and running. Let's try to assign, as we have configured the router with sub interfaces, and also as the router is a DHCP server, let's try to get one IP address from the router for VLAN 10. Let's see if you are able to get it. It failed, and you can see DHCP failed, API is being used. Why? So let's check it. We have configured the trunk interfaces on all these interfaces that are connected to the switch, but we haven't configured fast Ethernet 0/24 interface as trunk. So let's try to configure fast Ethernet 0/24 as trunk switch, because if you configure trunk, then only the VLAN information will be transferred from the router or from the switches to the router and switch router to the switch. Okay, now let us see. Let's wait for a while until the trunk interface comes up, and then we will try to get the IP address from the DHCP server, which is the router. Let's wait for a while until the interfaces come up. You can see here. Let's see. Show interface trunk. You can see fast Ethernet 0/1 on the switch is trunk, fast Ethernet 0/3 on the switch is a trunk, and fast Ethernet 0/24 is trunking. Let's try to get an IP address now. Let's check. You can see here the DHCP request was successful and we are able to get IP address from the router. Let's get another IP address for VLAN 20. Let's see. You can see here it has already got the IP address. Let's get it for VLAN 30, and let's see. You can see we got the VLAN 30, and let's try to ping all the PCs. Let's try to ping all the PCs and see if we are able to get the IP address. and if we are able to reach, let's try to ping ipconfig. You can see the IP address 10.3 is assigned here. Let's try to ping the route, ping 192.168.20.2. Let's wait for a while and let's see if we are able to ping. Wow, you can see we are able to ping the VLAN 20. Let's try to ping VLAN 30. Wow, you can see we are able to reach all the PCs of the network, and we have configured only one interface on the router, and we have used sub interfaces for all the VLANs that are in the network. So, and as the lab suggests, we have configured the VTP servers, we have configured the trunk interfaces, we have configured router as a DHCP server, and also router on a stick or one armed router. Why it is called as one armed router? Because we are using one router for multiple VLANs, or we are using sub interfaces of the router for configuring multiple VLANs and routing between the VLANs. We have performed all the tasks, we have verified all the connections and confirmed the reachability of all the PCs as the lab suggests. We have configured the switch 1, switch 2, switch 3, and we have configured the interface connections. We have configured the VLAN configurations. We have configured sub interfaces. And on the switch 3, we have configured VLANs, and the VLANs were synchronized to the VTP client from the VTP server. We have performed all the tasks and we were successful. So if you like this video, just click the like button and subscribe to the channel. And if you have any queries, you can just put a comment and I will be happy to answer your query. Thank you for watching the video, and we'll see in the next lab. Thank you. You all have a good day.